So water is going to be one of our polar solvents. In fact, it's one of our favorites because it's pretty environmentally friendly. After all, it's a big chunk of what the planet's made up of, right? Now, the great thing about water is it's polar, and that means it has partial positive and negative charges on it, but the whole molecule itself is going to be neutral. Now, let me contrast that to H2. The H2 molecule is going to be totally nonpolar because you have two completely equal atoms doing the sharing. But when you have water, you've got an oxygen in there, and the oxygen is going to be much more electronegative than the hydrogen. As a result, the oxygen pulls the electrons really strongly. Hydrogen, yeah, not so much. As a result, the electrons are tugged over to this side, giving this, well, they're shading it as red to show the negative charge. Over here you see the blue shading for positive charge. This is actually coming off of a supercomputing setup in order to determine exactly what it would be. You can see there's a tiny bit of negative bias right there in the center of H2, just a tiny bit of positive bias on the outsides. That's purely from just how likely you are to find the electron right here where you have two protons tugging at it, versus over here where it's a little bit less likely to be since spending more time in here. That's going to be something that matters a lot when we start talking about intermolecular forces. But for today, key thing to point out is this isn't going to be sticking to things very strongly, but this one really will stick strongly to anything with a charge. That's because we're going to have these two dipoles here. You're going to have this partial positive and partial negative end, and as a result, the whole molecule gets a big dipole moment. Since it's going to be so polar, it's going to be able to act as a really good solvent, something that dissolves other things, when those other things happen to have a charge on them, either because they're polar or because they're a full-size ion. So water is going to be able to actually work with those. Now, in a separate video, we're going to see that I like to kind of give water a model where I treat it like a giant ant with a giant jaw, like in the horror movies from the 1960s, grabbing hold of something and just dragging it away. That's a good visual for what we're talking about when it comes to things dissolving and things being pulled apart when they're dissolved in water.